Okay, 8-3. In 8-3 what we're going to do is we're going to add and subtract rational expressions and look at dealing with some pretty complicated fractions. So when you add or subtract rational expressions, it's pretty much similar to when you were adding fractions back in elementary school and in middle school. If you already have a common denominator, it's pretty straightforward, right? When you have 1/5 plus 3/5, you have 4/5. If you have 6/7 minus 4/7, that gives you nothing more 2/7. So we're going to be doing similar things, but just doing them with rational expressions. So take a look at this one here. Let's add these two together, and then after we do that, let's identify the undefined values. So take a good look at these two fractions here. There's one thing that both these two fractions have going for them, right? And the fact they have a common denominator. So remember, whenever you have a common denominator, for example, like this right here, if we have 5/7 plus 4/7, that equals 9/7. One little tip that I'd like you to go here at understanding how to deal with rational expressions and adding them together is a little middle step here, going from the left side of the equation to the right side of the equation. Working on behind the scenes here, why don't we look at this like this and have it be 5 plus 4 over 7 is one fraction, and then go the extra step and then write our 9/7 just like that. So what you see right here, we're going to put into play with these rational expressions here. So we're going to add the numerators, just like this. And so that's that move you were seeing earlier where we were writing it as one fraction with the two numerators separated with the plus sign. So here we got to take 3x minus 4 and add 2x plus 5. Really nothing major happens here, especially when you have a plus sign here. We're really just distributing a 1 into that 2x plus 5, so those parentheses really don't mean much. So then what we're going to do is just combine like terms. The 3x and the 2x combine together to give us 5x, and then the negative 4 and the positive 5 can combine together to give us the 1, right? So now I have 5x plus 1 over x plus 3. Now let's address the undefined value here. Same as what we did in the previous 2 days here. The undefined value is just the value in the denominator that for x that'll make the denominator equal to 0. So understand that negative 3 will do that. So if negative 3 is our undefined value, just remember that you could have answered this part right here by saying, well, this is my solution, and then we can say that x can't be equal to negative 3. Let's see what's the haps with subtraction problems like this. So really the first thing that you notice here, once again, should be that we have a common denominator. So if we have a common denominator, we can write this as one fraction and we can subtract the numerators. Now notice what's different about this one. Because we're dealing with a subtraction problem here, with the subtraction problem, what we have to be aware of is that we want to subtract this entire quantity here. So when we want to subtract that entire quantity, what you're going to have to do every single time when it comes to subtraction problems is always distribute that minus sign to both of those terms, or however many terms you have on the second fraction. So we distribute that minus sign there to the positive 4x and the positive 4. Now what we have is minus 4x and minus 4. And then we can combine our like terms here. So when I take my 2x and subtract my 4x, that would give us negative 2x, right? And then when I take my negative 1 and minus 4, that should give us a minus 5 all over that x squared plus 2. Now, what about the undefined stuff? Take a good look at this denominator here. This denominator is x squared plus 2. Are we going to be able to find an undefined value? In other words, can we find a restriction for this denominator or a value that will make this denominator 0? I don't think so. Let's picture the number line here. Think of any positive number you can think of, and you plug a positive number in here for x. The positive squared is going to be a positive. When you add 2, the end result, we're going to get nothing but positive numbers here when we plug in a positive number here. We're never going to get 0. Reverse it. What if we plugged in a negative number in here for x? Well, wouldn't that still create a positive when we square it, and then a positive plus a positive? We're nothing but positive here. If we look at just 0 specifically, that's going to be 2. So notice that no matter where we go, we're going to get a positive value here. So in other words, this expression is always defined, so we actually aren't going to have an undefined value here. And sometimes that happens. Will it happen a lot? No, it won't happen a lot. So when you look at that denominator there, just give it a good look and just make sure that it might actually be defined. Okay, so 2 examples here. I'm going to let you guys work on these ones for a couple minutes, and we'll end the video here, and then substitute, if you would please move on to the next video, and we'll go through the solutions here and show them the rest of the work that is in front of them. So give them about, 5 minutes or so. Be careful with that subtraction problem over there with example 1b.